This week we're going to talk about Linux firewalls. Before we look at the firewall configuration, let's take a look at our network and see the different networks that were connected and the routing tables. So the command to look at your network configuration is ifconfig. And on my virtual machine, I have my ETH0 interface. And then I have an alias for it, which for the purposes of this um, for the purposes of firewall, they both just are on network, so really not a big difference there. But if you look in here, I have another interface, ETH1, and ETH1 is on a different network. So the ETH0 and ETH0:0 were both on the 118 network. ETH1 is on the 120 network, and they're on separate networks. So for this week, we are assuming that ETH0 is our publicly facing network, and ETH1 would be the network where private stuff is, so where our users come from. And if they go out to the internet, they would go through this network here, which is the 118.40. Okay, so normally when you have a system at home, and if you put Linux, you're gonna have two network cards. One that connects to your DSL connection and actually gets a public IP address, which for the purposes of this assignment, we're making it ETH0 on our machines. And then you would create a local network for all of your clients to have IP addresses on, and for our purposes, that's the 120 network. Okay. And on your system, you're only going to have there's only one default gateway, and that's where all the packets would go if it can't find a route for a particular network. So to figure out what the default gateway is for your system, you do a netstat -rn, and in our case is the publicly facing interface, which is the 118.1. Okay, so it's on the 118 network, and that one is the default gateway. There are several ways to use a firewall. You could use a firewall to protect an individual server. You could use a firewall as a network infrastructure device, in which it would be your default gateway for all of your clients on your local network. So you have a system with at least two network cards, one to the public internet, one to the private side, and all the private side computers would use it as its router or default gateway, and also as the firewall, because they would all have to go through it to go to the internet. So that's what we have there. Now, what I've done for this week is I've created a firewall configuration file with different rules. And basically what the rules are, the rules say that any client on this network can connect to your machine and view all the services that you're offering, but which is in our private network, so we're okay. So we trust our private network, and we allow everybody to connect to our services. But then anybody on this network, which is our public network, we will only allow access to servers that we specify, like SSH, HTTP, and web and the mail stuff, SMTP and IMAP. That's it. The rest, we're closing our ports too. And let me just show you here a screen. I ran the nmap utility, and what nmap does, it basically does a port scan on an IP address on a server and checks for all the open ports. And what I have done is I have taken that firewall configuration file with all the firewall rules, and I have saved it on this machine. And here I ran nmap first on the public side, which is the 118 network, and as you can see, only two services are open, SSH and HTTP. Everything else is not, it's closed through the firewall. Now on the private side, which is the 120 network, there I have everything open. So as you can see, FTP is open, DNS is open, IMAP is open, and a few others. So this is my trusted private network, and I allow all the other hosts on that network to see it. This is my public net, which I assume is facing the internet, and I don't want everybody to see my other private data. So I am only opening 22 to administer my server and 80 to do web stuff. Okay, so so the first thing you want to do is you want to activate your IP tables service. And what IP tables does is it saves all of your firewall rules to uh, the etc sysconfig IP tables file. So when the service starts, it reads anything that is in here, and that's what it applies. And here it shows basically all your firewall rules, and I will go through and explain what some of these things mean. So if you do an etc, if you do a service IP tables start, it will read what's on this file and it will apply those rules. Now to stop the firewall, you could do IP table stop, and that stops it. Okay. Now, if you want to see if you have any firewall rules active, you could run the command IP table save, and that will show you. Right now, we don't have any. So what I'm gonna do is I'm gonna run this firewall sh file to activate all those rules. Okay, and it's apply those rules. And what I want to do is run the command service IP tables save. What this will do is it will save my current configuration over to that etc sysconfig IP tables file. So if I reboot, when I reboot back, it will remember what these are and it will apply them. Okay, so it's like it says here, it's saved those files to this file. And now if I do IP table save, I can see that they're there. Okay, so now let's talk about IP tables a little bit. No, before that, there's one more thing I want to explain. And I have 2 network cards on this system. And if you want to activate port forwarding, not port forwarding, but IP forwarding, to do that, you have to modify a kernel parameter. And in general, for Linux systems, the kernel parameter are found. To modify kernel parameters, you have to modify a file, and the file is the etc sysconfig, no, etc sysctl.conf. Okay, and packet forwarding, it's controlled by this particular parameter here. Right now it's set to 0, so all of the kernel parameter stuff uh, uh, entries are saved in the proc file system. So you can actually find out what they're set now by catting different files in there. So for IP forwarding, you can cat the file cat proc sys net IPv4 IP forward and see what it's set at. Right now it's set at 0. So what we want to do is we want to change this file. We want to change this instead of 0 to 1. Okay. Then we want to save that file. Again, that's the sysctl.conf, and that's used to modify kernel parameters. And since we've modified, now we need to apply those changes. And to do that, we want to run the command sysctl-p. Okay, that applies all those. And now we can cat that again, and as you can see, now it's changed to 1. Okay, if you reboot, since it's saved on that file, it will remain there. Another way of doing this is to echo 1 to this particular file. The only problem with doing that is if you do it that way, it will work right now, but if you reboot, that would get lost. So the best way is to just change it here, then apply it with sysctl-p, and then IP forwarding is set. And what that does is allows the forwarding of packets from one network card to another. So incoming packets from the public interface can be sent to the private interface, and packets coming from your private side can go to the public side and then out. So most machines, when you configure them as firewalls, will, for the most part, require IP forwarding as well. So, like I said, now let's talk about the IP tables or net filter packet filtering utility. So I'm going to VI this firewall.sh file, and we're going to take a look at this a little further. Um, Basically, uh, all packets inspected by IP tables pass through a sequence of built-in tables, and they're processed by these tables. Uh, and each of these tables is basically dedicated to a particular type of activity, and it's controlled by an associated packet chain, which then filters that further. Okay, and NetFilter comes with three of these built-in tables. The default one, which if you don't specify it on the command, it's the default one, and that's the filter table. It's the default table for handling network packets and doing packet filtering. Two other ones are NAT, which is used to alter packets that create new connection and used for network address translation, and I will explain what that means in a little bit. And finally, the Mango table, which is used to alter packets for quality of service purposes. That means to restrict bandwidth. Um, Now, associated packet uh, filtering chains for each of the tables are basically, you have the most popular ones are input, output, and forward. Input alters packets that are targeted for your network. So if you were running SSH and you wanted to open the SSH port to one side on it so users can connect to your server, you would use the input chain because they would be connecting to your machine. The output chain is the one for packets that go from your machine out to the world or any other host. And the forward chain are for packets that come from another host and go through your machine as they get routed out. Um, but regardless of their destination, when packets match a particular rule in one of the tables, a target or action is applied to them. And these are specified by the -j command, and the most popular ones are accept, uh, to allow that packet to continue, drop to send back the packet to the host, and reject where the packet is dropped but an error is also sent to the user that sent that packet. Okay, so let's take a look at this file. um, First, what I'm doing here, I'm loading a few of the modules. So since I'm going to do NAT and connection tracking, I've loaded those modules. Then I'm clearing any existing firewall rules just to make sure I'm flushing all this stuff. And then here I'm setting my defaults. So um, the way IP tables works is if you have a rule, as soon as you match one rule, uh, it basically goes from there and it takes that rule and goes with that. But if it doesn't match any rule, it uses the defaults. And what I'm doing here, I'm saying for input, which are connections to my machine, my default rule is to drop any packets. So I'm dropping any connections that come to my machine unless, if there's no rule matching, it will be dropped. So which means I won't allow anybody to connect. So what I do is I first set my default to drop, and then if I want to allow anything, later on I specify a rule to allow that. And then for the output, since in this case I'm configuring this for my host to use as a infrastructure firewall, I want the outputs or packets that are going to go through my firewall to be accepted. Okay, here what I'm doing is I'm allowing any connections from the local host. Okay. Um, One of the nice things with IP tables is that it has the ability to keep track of state. Okay, and state is very important because And the two basic states that you have are, or three, are new, established, and related. So here I'm saying any connection that goes through this interface, which has a state of established or related, I want to accept. And these are so that, let's say I start an SSH communication from this machine out to the internet. Now, when I do that, I did the new connection, but then the machine that I'm connected to is going to reply back to me. And that would be established state because I established the connection and the other machine is replying back to me. And when that's the case, I'm telling it to accept it. Okay? So having this state really simplifies things. Otherwise, you would have to have one rule for each of the services when they respond back. Okay, now what I have done here is, so for the ETH0 interface, I'm saying anything that is established or related to accept. Now for ETH1, since it's my private site and I want anybody from my private site to connect to my services, anything that's new, established, or related, I want to accept. So here also the new are added. In here, I'm not adding the new, so nobody from the outside can connect to my services yet, because that would be a new, and I'm only allowing it for established and related. Here I'm saying anybody from my private site, if they want to do a new connection, go ahead and accept. Okay, so right now nobody from my ETH0 or public interface can connect to any of my services, and I want to open a couple of ports. I want to open 22 and 80. So what this is saying is any connection to my machine input on this interface, which is my public interface, that come in on this port, which is SSH, and then another 80, and whose state are new, so it's a new connection, then I want to accept. So here I didn't tell it to do new by default like I did on the private side. What I've done is I'm being real specific as to what I want. So for your assignment, if you're asked to add more, to open more ports to the firewall, all you have to do is just find out what the port is and basically run the same command. The only difference is going to be your destination port. It might be, if it's SMTP, it would be 25. If it's IMAP, it would be 143. Okay, here I am allowing the protocol ICMP for pings. This here is not really important, but basically it's to drop any broadcast packets. And finally, a couple important rules that I want you to know, not for the assignment, but just in general, if you want to set this up at home, is here like I said, we have three built-in tables, and in previous ones we didn't specify the filter table, and that's the default. But here, these two actually are using the NAT table, and what NAT does is network address translation. And what it does is there are three sets of networks that have been allocated for private site IP addressing. And in our case, our network 192.168.120 and 192.168.18 are private networks. They really are non-routable networks. So you cannot go to the internet with an IP like this because it's a non-routable. It's an IP that won't work on the internet. So on your machine at home, your ETH0 would be your public site interface, and you would get an actual IP address from your service provider, which is routable. Now your ETH1 then would be something like this: 192.168 or 172 or 10. And those networks, like I said, are private site networks, and they need to be NATed or translated so to the IP of the public side. So anything that comes from the internal network, from this, if it wants to go to the internet, the packet needs to be changed so it looks like it's coming from the public site IP, the one given to you by your provider. So what NAT does is it changes the packet and it changes the IPs so that it looks like it's coming from the actual public IP, and when the packets return back, they get changed so that they go back to the private side. So it keeps track of all that information. So this rule here does the IP masquerading or network address translation. And what it says is any packets from the private side with destination of anything, so going to anywhere, I want you to masquerade using the IP of ETH0. So any request that goes through the firewall from this network, when it goes out and goes out to the internet, change it so it looks like this, the IP of ETH0, which in my case is still a private site IP, but if this was at home, it would be a public IP that you can actually connect to the internet. So that's IP masquerading or network address translation. Um, the other important one is port forwarding. And what port forwarding does is, so now you have this public IP, and but you actually want to connect to a server inside your network that is not your firewall or where the IP is set. So your public IP is set on your firewall, but you actually want to connect to FTP on a machine inside your network on the private side. What port forwarding does is it tells the firewall that anything that comes on a particular port that you specify can be then forwarded to an internal host. So this command here says anything that comes to my public site IP on port 80, the HTTP port, I want you to DNAT or forward to internal host, which is on the 120 network on port 80. So then if you went from the internet and connected to this IP on port 80, it would actually forward it to a different machine on the internal side on port 80. Okay, so that's basically all you need to know for Linux firewalls for this week.